My name is Luke Reeves. I work at a place called Shopify up the street. We use GraphQL now. We've been dabbling with it for a while, and this presentation is sort of going to be half explaining the basics and why you'd want to use GraphQL and how you'd use it, and then it'll dive a little deeper into how Shopify uses GraphQL with various different components. So let's get started. And you can ask questions anytime. Just raise your hand, and we'll ask questions at the end as well. So everyone here probably knows REST APIs, I hope. If not, this is really the wrong meetup for you. Everyone knows how they work. Generally, you ask for a resource, a plural resource. You get an index resource back of a whole bunch of things. In this case, we have orders, we have customers, and what happens is we flesh out these models in our app, and then all the clients have to know how to ask for these. They have to know which route corresponds to each model, and they have to know what fields are in each model. So what happens when you build mobile apps is you end up in this kind of crappy experience where you're doing multiple round trips to build a page view. So if you're an iOS developer or an Android developer, you might be building a page at Shopify to talk about a shop. Say I'm a shop owner, or as we say, a merchant. I'll have a shop page that has a bunch of customers, a bunch of orders, and so on. A lot of times you'll have to naively make round trips for every component of data. So you ask the server, what customers does the shop have? What orders? What products? What inventory counts are? Et cetera, et cetera. So REST starts getting a little crappy there. So what we, and not specifically at Shopify recently, but what a lot of places have done is you start to break down endpoints like this. You start to have to add multiple different kinds of resources to one endpoint, which if you know what REST stands for, and I actually don't even remember, resourceful entity something, this completely destroys it, right? Breaks the whole point, and you don't want to do this. And then what gets worse is your clients are never in sync, so you're going to get this, which we do have at my last job and at this job, not with the actual words, but we all know which endpoints are used by which clients, and I'm just looking at specific people right now. Then we also have this. Versioning in REST, you can do it 1,000 different ways. Some people use a header to pass in the client's version. Some people pass in a header of what server version they expect. Some people use a date. Some people put it right in the URL. It all sucks. You don't know what's going to be different from a client perspective between each version that you're asking for without fully having documentation for everything, or just basically trying every endpoint, maybe having fixtures saved in your iOS repo, et cetera, et cetera. So that really sucks. And REST also, if you know SQL, is select star by default. So in a REST implementation, pretty much all of them, they will always return every field for models coming back from the database. So say you have the product in Shopify, we will always return, if you ask for /products.json, the title of the product, the vendor, the SKU, the inventory, how many variants it has, every field we know about, we're going to return. So that leads into the next part, which is every implementation of REST usually tries to fix some of these things. What I just talked about is called field selection. So a lot of REST APIs will have like a parameter that's like $fields equals title, right? Which sucks for a lot of reasons, because then you have to document every REST endpoint and say if you support that or not. And a lot of different servers will call it something else. Some call it included _field, some call it fields, some don't support it. Sideloading is another huge thing that basically anyone that's built any API wants to eventually do. Sideloading is the process where you ask for related objects. So again, going back to Shopify, since everyone understands the concept of a store, if I ask for a shop, I might also want products and customers. So because REST is not a standard in any way, different implementations have different ways of asking for sideloaded fields. You might have a parameter called embed fields, embed objects, include objects, all kinds of crap. And again, going with this theme, it really sucks. Identifiers, primary keys for all your objects. Again, there's no real specification in REST. I don't think there needs to be, but it's one of those things where not having consistency means that you have to know when two objects map to the same thing in your API. So a good example of that is, say, again, with Shopify, you have users, customers, and merchants. Maybe those are all actually a person model on the back end. You have literally no way of knowing, because we're just going to return you a number, right? We're going to say user ID is 1. You won't know if that's actually a person object backing it and so on. You can get around that again, but it's always going to be specific to your REST implementation. Deprecation of fields. This is an awesome one. And again, I'm going to look at the Score people and Shopify people because both companies I've worked at now with mobile clients run into this problem all the time. You always expose stuff in your models that you regret exposing. Inventory is a perfect example in Shopify because we never want to show someone in the REST API publicly the inventory of a product. It's crazy, right? Like if something's on a hot sale, you know a bot's going to buy it. So we don't want to show inventory. However, if you have a million iOS clients in the wild in the App Store, removing that field or just nulling it out becomes impossible. So you might come up with a workaround and say, oh, this lipstick has 0 quantity, which sucks because it doesn't have 0 quantity. You want the user to be able to buy it. So there's no clean path in REST to remove fields that you want to get rid of, which sucks. And then the last piece is missing and null fields. This has caused me endless pain through my entire life. You'd never know when a field comes back null what the hell that means as a client developer. And that client could be another Rails app talking to a Rails app, could be the mobile app, could be JavaScript. But a null field could mean that maybe the field doesn't exist anymore. Maybe the database truly does have a null for that field. Maybe it means you shouldn't show it. It really is literally an absence of data that is up to interpretation for you. So if you've used any newer languages, such as Swift or Rust, a lot of newer languages do focus on this concept called optionals or maybe, which tells you right up front what can be null. REST has no convention around this. So you will never be able to get that without your client intimately knowing the schema of the server. If you're developing a server and expect public use, you'll never really have that level of communication where you say, like, on this baseball game, player is null because the pitcher got hit by a bus or something, right? You will never be able to tell every client to use the data that way. So this is REST. This is how it feels. Props to Jessica for the GIF. Why we switched to GraphQL, there's a ton of reasons, and I get asked this a lot. This is not all of them, but I'll quickly talk about each of them in turn. One endpoint. When you're building out a REST system, I showed you earlier, you need admin/orders, admin products, users. Every resource basically needs another route. And in Rails, for example, you will be adding another configuration to your config/routes file. It's not fun. It's not hard, but it's boilerplate garbage. Like you're not programming, you're just doing data entry at that point. There's one query specification for GraphQL, which means that everything you want to ask for, you know how to ask for it from the specification. The GraphQL spec, paired with the relay specification, it's called, from Facebook, flesh out every edge case so far that you can probably think of when it comes to asking a remote server for data and specific parts of objects, fields, and so on and so forth. We'll cover some examples in a bit. The next part is mutations. What I didn't even talk about in REST was changing data, which happens time to time. Clients might want to order something in Shopify. Or if you're running a popular sports app, you might want to subscribe to a team. So in those cases, you'll want to mutate or change state on the server. Mutation is kind of a weird, very academic word to use for it. I'm not sure why we went with that, or they went with that. But a mutation in GraphQL is the simple act of telling the server you'd like to change something. GraphQL is kind of cool because it lets you actually respond with things that were changed. So if I'm changing a user's order in a mobile app, and I change just one line item, the server can actually return the whole order with all the line items in the response, and GraphQL clients will intelligently be able to parse that. That's all completely in the specification. So if you're using a client that is not terrible, the reference clients are pretty good. Some of the ones we're working on at Shopify are pretty good, I hope. Then you will get all of this for free with GraphQL. The response is another specification component. It's all JSON, which is cool. The GraphQL requests are almost JSON, and I kind of wish they were. Make my life a lot easier, but I'll show you a request shortly. They're very similar. But the response that comes back is very easily parsable. So if you're just playing around with GraphQL, making a test app, or playing with a new endpoint to see how it works, GraphQL is ultimately readable, very simple to parse. It gets a little hairy and gross when you get into paginated sets, and I'll show you why. But out of the box, very consistent. Error specification is interesting. A good example of this is in REST, if you're changing something, for example, changing a user account details, if you update the user's email address, there is literally no way as a new developer without either reading up-to-date docs or trying out stuff, you're not going to know what happens if you update the email address to something that's invalid, something that's already taken by the system, or a missing email address. So GraphQL gives you a very consistent way to return a top-level error, which basically can say like, oh, our database went away, or a user error, which tells you which fields you actually tried to change that broke. So if you're used to Active Record, there's a very fantastic framework in Active Record for validations that says an email address has to be minimum 5 characters, has to have a period, has to have one and, or at symbol. We can actually return that in the response payload and have the clients directly render and highlight the field that caused the error, which is pretty cool. This is what, can you read that, kind of-ish? This is an example query. So when you sort of look at it and squint, it's JSON, but it's not, which really sucks to parse. This bracket and parameterized list is how you specify arguments to things. This simple query is asking for a single product from Shopify, the title, et cetera, all of the variants, the price, and the options. So in Shopify, options are like the color of the hat, whatever. And this is pretty useful because you can see right away, in GraphQL, there's a consistent identifier that's a global ID across your system. So it's a GID that lets you namespace your entire identifier to the application or company, which Shopify here, and then the actual model. So when I was just talking about if you ask for a merchant, you don't know if it's a user or whatnot. With this scheme, if you ask for a merchant, you will always get back an identifier that can bring you to the actual resource of that object, which is fantastic. It's very nice. Because I'm going through the primer, maybe afterwards I can show you the live response to the payload and this stuff, but let's keep barreling through for now. Is everyone good? Questions so far? Is this crazy or not? Okay. So, part 2 is GraphQL at Shopify. I don't know if anyone noticed, but about 2 weeks ago we released a new mobile Shopify client for iOS and Android. This is our merchant application. So if anyone that wants to run a shop in this room signs up for Shopify, at least 50% of you will probably do most of your administration now through your phone, through your mobile device. So we launched a brand new 2.0 version of our entire mobile platform called Mobile Shopify, which came out, I think was actually released now 3 weeks ago, to be fair. The entire app is powered by GraphQL. I think every single transport connection now is GraphQL from that app to the Shopify Rails servers, which is fantastic. It's also kind of a public secret. We're going to announce that at GraphQL Summit next week, so like, don't tweet it and get me fired or anything like that. I don't think that would happen, but let's not play with fire. So at Shopify, we have a lot of APIs, and I mean like probably over 20 REST APIs. Some are public, some are private, some are like public, but we don't tell anyone about it unless they need to know, which really sucks to support. Some are documented, and I mean like some are documented fully, some have half their documentation done, and it's really kind of like a mess. That's not like a criticism, I think, because we are probably running one of the oldest Rails apps out there. I think you have to evolve to this point, right? It's not like we intended to make 15 to 20 APIs. It just kind of evolved to this state. So we really needed something to unify all the features that we're rolling out faster. What happens at Shopify is we will build new features in the core app that the APIs exposed to our third-party developers can't keep up with. Additionally, internally, we always try to use our own APIs to develop stuff. So, for example, I exposed a concept called product publications recently in an API. And when I did that in the GraphQL API, you also have to be like, oh, yeah, these other things have to now know about this. I have to update the documentation. And that becomes very arduous, especially if you're a new developer. You don't know about those 15 APIs. I certainly don't. And they will always have problems keeping up with the core logic of what we built. And then documentation is nice to have, obviously, but it's never up to date. Either you're going to miss fields, you're going to miss endpoints, you're going to miss entire APIs with your docs. Unless you have teams of people working on docs, actually, we do have a team, and we can't keep up. We have literal teams of people. Actually, David probably knows more than me. He's been at Shopify a lot longer, but we absolutely have like a team of people for docs. And we can't keep up with the APIs. They'll often open GitHub issues being like, oh, someone's asking about this API call, and I can't find it in the docs. And we're like, how did they even find that? Because it's there. So we needed something to really power a new generation of APIs. Oh, there's this picture, totally out of order. there's our press release, which is super exciting. I can show you the app later. So we built a brand new API, but then sort of made 2. We don't want to have 15 again, but in our space, there's a very concrete segregation between what a merchant does at Shopify and what a customer does. So if you're buying shoes and you're selling shoes, those are completely different APIs and experiences and access control levels, right? You, as a consumer of shoes, should never see what tomorrow's price will be, for example. That API should be completely segregated. So we've created 2 new APIs, one called the merchant and one called the storefront API. I guess I'm partly responsible for the storefront one, and as it turns out, more responsible than I hoped for the merchant one, so I'm very involved in this stuff here. And so far, it's been pretty interesting. We've built the entire backend in Rails, because that's Shopify, of course, using a open source GraphQL Ruby gem called GraphQL-Ruby, which is pretty awesome. Interestingly enough, we started working on GraphQL about a year ago. It kicked off at a Hack Days, and the GraphQL gem was very much not ready for prime time. So inside our code base now, we actually have implemented a bunch of GraphQL features from the spec that the public gem has not kept up with. But now we've actually contributed a lot of that back, and we're like in communication with the author. So there's this kind of cool ecosystem now where we're actually contributing back and forth. It's pretty fun to work on. So as I mentioned before, because we're cutting off all these REST APIs eventually, we get to actually drop every field that we never wanted to show in the first place. So there are things dating back a dozen years in Shopify's data model, such as pricing. Pricing that existed when like the most complicated thing was, is it US or Canadian dollars? There are all kinds of weird pricing problems we have to deal with well past that. Locale is another thing that we really didn't think of at the start, but because we gained mass and users so quickly, it was impossible to change as we were flying. One weird example is products have a weight. If you're shipping a product, it weighs something. So the original schema is in grams, which makes pretty much no sense if you're selling like car tires and stuff. So we ran into problems with like integer overflows and stuff because grams is a pretty tiny thing. So this let us completely throw all that crap out and start again. And again, I don't mean to insult by saying crap. One of those things that we now do is we return fields in the GraphQL API called weight unit and weight amount. Right? So we can actually let the merchant select if kilograms is most appropriate for what they're selling, grams, if they're one of the many pot vendors, things like that. So that's a joke. I don't think anyone actually sells pot on Shopify. They do? There's certainly paraphernalia, but we also have deprecated field usage now. Because you can actually decorate your schema with what's deprecated, you can now tell on the server which clients are asking for bad fields. So when we remove a field now, I can show you a screenshot later. We actually have like a Splunk and Datadog dashboard that shows us which versions of which clients are saying, hey, give me weight in grams. And we can actually, if it's an internal client, we can go to the team and say, please update your clients. We're going to remove this. Or we can, in the case of a third-party developer, email them directly and ask them to fix their code, which... because this is not open to third parties yet, we haven't hit that part, but the first case where we're internally changing stuff has already paid off. It's really super useful with the mobile Shopify launch to be able to pull fields that we thought we would need, but then we didn't in the end. This is kind of Rails-specific stuff, and I will talk quickly because most of you won't give a damn, but Shopify has this pretty popular Rails gem called Identity Cache. This is a powerful tool that lets you take any of your database models, stuff them in memory, and fetch those from then on. We would basically be crushed under our own weight without this. GraphQL lets us use that exact same functionality. So when you're asking for the title of the shoes for sale, but someone else is asking for title and the price, all of that entire model is still stored in memory in our server, and we just return only the fields you want. Additionally, N+1 queries is one of the first things that we and probably a lot of other developers have hit with GraphQL and any other database mechanisms, surely, where, for example, if you wanted all products plus all the images for those products, a lot of naive implementations will ask for the products list, and then for each product, make another query to ask for the images. That's called an N+1 query. It sucks. It means there's N objects, and you're adding +1 query for everything. And we have had N+50 probably at times. So GraphQL lets us use promises in Ruby to batch up what is being asked for in a request, and then only when we're ready to send the request do we serialize those promises into one actual database call and fire that back to the client. So if that's interesting, ask questions about it later. Again, it's pretty Ruby specific, but we do have an open source gem in the Shopify repo called GraphQL Batch Loader that does all that magic for us and was obviously written by us. Not me, sadly. I'm not that smart. This is what the Ruby implementation looks like. What's interesting is that a lot of our mobile developers vastly prefer this syntax to anything else that we use at Shopify, whether it's active model serializers or JBuilder or any of the other 15 serializers we've tried in the past. It's a very straightforward, simple DSL that lets you say what fields from the database are going to be exposed in GraphQL. You can actually override fields. So when we say expose a field as a billing address, we'll actually call the database attribute called address, because we quickly realized in this grand schema of things that address here actually represents the billing address, but a shop might have multiple physical addresses, right? So this gave us an awesome example to finally fix that so that new clients don't have that kind of shitty legacy behind them. There's the currency. This is another good example. This is like live code I think I pulled, where we're telling in our Ruby DSL that this field is deprecated and you should not use that. And you can even put a nice little description there. You can actually now use like Markdown in this, so when you're generating documentation, you can have like full-on chapters of text as to why not to use this field. I don't know if you would, but it's kind of cool. And then we tell the person to use the next field. Each of the fields have a strongly typed type. Here it's a string. Here we actually have a custom type called currency code. And here we have a custom database type called staff member. You can basically go as deep as you want with the type system. One of the things I didn't really touch on with the JSON REST API style, and I should have, is typing sucks. When you're getting back JSON, unless it's a string or it's JavaScript, so I guess like a floating point number, you really don't know what the hell an object is. If it's a time or a date time or a timestamp, it's going to be a quoted string, and you have literally no idea what format that could be in. So GraphQL at least gives you super strong typing for all of that stuff, and that has saved our lives certainly. Oh, and the last thing is we can actually say which fields here have to be paginated. The idea being that we don't ever want clients ever asking for fields that could have millions of rows. So we learned the hard way with REST that we can't do that anymore at our size. Anything that we think might only have a maximum of 100 never has a maximum of 100. Like we thought a product would only have 1,000 variants, and that was like super wrong. We thought a shop would only have maybe, I think, 255 staff members. Like imagine like you're running an online shop, you have a max 255 staff members. That was like super wrong. Now it's thousands in some successful shops. So now we force pagination. The clients have to actually understand a very different syntax to ask for paginated set, and time permitting, we can talk about that. But that's basically it. And then in the Rails world, if you actually want to override the automatic mapping of a method here, you can actually pass in a lambda or a proc and say, this is how you get that field for whatever. So in this case, we're mapping the staff members to shop.users. And that's actually what our real serializer looks for the shop object, which is arguably one of the, if not the oldest model we have, one of them. And it's like the active record model for that is a lot of lines of code, like tens of thousands, I would say. The schema is generated. It's human readable. I wrote fairly readable instead of human because it's, I don't know. We'll see. I think that's readable personally. It's literally just an entire list of the types and the fields they contain and what their types are. So it's recursive because it's a graph, obviously. So an address might have like a subfield that refers to another object, but it's pretty straightforward, nothing crazy there. Based on that schema, you can actually do interesting things that we will talk about in a second. The mutations are a little more complex because you're actually changing data on the server. So in Ruby, this is a sample of implementation that creates a product. I'm pretty sure I wrote this code, or some of it. Oh, I wrote this legacy mirroring stuff, definitely. This was like 3 days of my life to figure out how to write something. It was a dark time for me. So this is literally it. We create a lambda that actually does the resolve here. This is the only place where we really break the DSL world and we actually just drop down into Ruby. But this is just standard Ruby code. Do whatever you want. Touch whatever models you need to or create. And then you can specify what fields are returned from this mutation. So when you're creating a product, we kind of we sort of guess that you might ask for shop, you might ask for product, but there's nothing limiting the user or developer rather from asking for more fields than that. Part 2 of the mutation is error mapping. So we actually take the errors that come back from Active Record and map them directly to GraphQL. So that, again, in the previous example, on the iOS and Android app, if you screw up the email address, only that field highlights in red with the message right above that. This is our scheme right now with Android and iOS apps. So we've taken that exact schema file, and we've used that to drive code generation for Android and Java and Swift to build out entire models of the entire Shopify core data system. And we've also sort of baked in a transport layer to make requests for those objects. So if you look in our Swift or Java repos, you'll see entire directories and subdirectories of every single model that you can imagine in Shopify. And the iOS Android devs can just simply invoke those and compose views based on those generated models. They run this fancy little script at the top. Sometimes it sucks because we found that some of the models end up changing and you want to run the script and then get diff and find certain things. But this generation strategy has actually proven to be pretty awesome so far, even though I had my doubts, because I think code generation usually sucks in Ruby. And it's worked out very well in the other 2 languages. I mentioned this, non-Rails devs are able to jump into the GraphQL serializers and actually know what the heck is happening there. And in our mobile app now, every page that you could possibly click on or touch is loaded in a single request to the backend, which is fantastic. We've tried that in other ways, and I have yet to see an easier way across JSON API paired with JSON schema and so on, or even what's the Netflix one, Falcor? I haven't seen any way that is quite as easy if you're building the client and the server to get that single round trip with everything you need for a user's view. And I think Relay at Facebook really drove that because it's completely thought about in a paradigm of what the user can see on their screen. The tooling is amazing in GraphQL. Because the schema is pulled from live models, and because the schema is parsable as JSON or an IDL file, if you're familiar with those, you can build basically any kind of tool. GraphQL, that's a really small thing, so I might be able to just alt-tab to a slightly smaller version. Okay, so GraphQL is a super popular one that everyone talks about all the time. This is a live view that lets you fire off GraphQL queries. Oh, thank God it works. And I'm tethered to Wind Mobile. It's basically the worst internet you can imagine. So this is a live GraphQL query. Lets you see the results in a pretty browser. It will do things like autocomplete because it knows the entire schema, which is super awesome again. So if I do inventory policy and click run, I now get it with deny as the end. I don't even know what that means, but there it is. That was a bad example. So GraphQL has another feature here, which is messed up because this is super hidden. But if you click docs, you can drill through every field here that's supported. So what Facebook and GitHub have done with their open APIs is they just expose the schema through this browser. Some let you run queries, some not. And you can see and build queries by using this graphical browser. You can actually also annotate every field with descriptions, as I mentioned, with Markdown, and get that as a nice document. We haven't bothered yet, because documentation sucks, I guess. So we've also done tests to integrate it with New Relic, where every single field that might be slow gets shoved into New Relic with a breakdown of which field recursively is slow. So you can see here, the shop was asked for, and then the shop's products, and then each product had their variant asked for. And we can quickly identify that variant/title is what was a bad query. I think we just put a sleep in there to test it. We have a Splunk query that I truncated because there was way too much data there, but we can actually see with this incredibly unreadable Splunk query what fields are being asked for that are deprecated. I thought I was a Splunk expert until someone gave me this query. But this basically looks in our Rails logs and finds every instance of a field that we've marked as deprecated being asked for. And it will split it by the type of client. So we can actually see that it's iOS version 7 asking for the deprecated field, which is cool. And we are now working on, hopefully, open source implementations for Ruby and JavaScript of a generic GraphQL client that works with more than just Shopify. we have found that there is a bit of an ecosystem around this stuff, but it is all very view-centric. So Relay, React, Apollo largely, and GitHub's new GraphQL work, all of it is centered around GraphQL stuff executing directly to show the user something visually. Whereas at Shopify, a ton of our stuff is executed by servers or in a Node app. All kinds of stores now use the JavaScript by SDK to basically write their own Ember app or Angular or whatever and embed Shopify logic. So we needed something that's more data-driven. So the syntax for the Ruby one, we're trying to make look like active record. This is like a live thing that actually works. And there's a Shopify thing in, I don't even know when it is. There's like a big conference we do or something like that in November and December. We would like to release, hopefully then, this open source stuff. So, you can, I guess, follow me on Twitter or whatever, and I will absolutely tell the world when it's released. And the JavaScript SDK largely looks the same. It's a little more strongly typed, but that's kind of what we're working on now. And we're definitely committed, but we're not sure if we're going to open up the GraphQL endpoint for anyone to just develop publicly against. That's fucking scary. Not to me, but to a lot of people, that's pretty scary. I think what we will do is open up the public-facing version of what I had mentioned as a storefront GraphQL endpoint first, because it's not really dangerous. There's no mutations to core data. It's only like placing orders that people would see. So we'll probably open that first. But our main driver right now is we will be building SDKs in the style of Facebook, where we write all the GraphQL code on the back end for iOS in our mobile SDK or in the JavaScript by SDK, and we ship you the SDKs, and you don't really worry about GraphQL. That's our current strategy. And we're trying to also figure out how much of an abstraction we want to give developers in these SDKs. A lot of the benefits of GraphQL come around when you know GraphQL, unsurprisingly. So we can hide a lot of that complexity, much like Active Record hides Arel, which hides SQL. But we're not sure if we want to expose an equivalent of all three of those levels or not. Currently, that's what our plan is, though. I hope I'm done. Yes, that's it. Thanks. That's my Twitter. So again, follow me if you want to know if stuff is released or if you want to see bad retweets of jokes. And thanks. That's good. That's it, I guess. And are there any questions? Yes.
How hard was the migration? Or actually, was there a migration from some legacy Rails stuff to this new setup? Did you have to?
Yeah, I mean, that's a good question. How hard was the migration for legacy Rails stuff? It was a lot of upfront work to get GraphQL to work at our scale. Now, if you're porting a Rails app, you could basically grab the off-the-shelf Ruby GraphQL gem because we've put a lot of work into that with Robert, the maintainer, and you can get flying really quickly. With us, we had to do all kinds of stuff around pagination, caching, identity management with those global IDs that didn't exist at the time. Once that bulk of the work was done, then it was smooth sailing. Now, if there's resources that we want to expose, it's less than a day to expose pretty much the most complex stuff at Shopify. It's quite nice. Yeah.
Which you use for your resources? So I went to the GraphQL Ruby project, and they have some documentation, but they didn't even cover mutations, for example.
Yeah.
And a lot of it was I finally got mutations working, but it was a lot of just banging your head against.
Yeah. Yeah.
So how were you guys literally just asking Robert on the Slack chat?
No. So that's a good question. The docs are terrible, mutations aren't documented at all. We started by writing code that generated the mutations ourselves based on the GraphQL spec. That's it. Yeah, and then we parsed that manually at first, as far as I remember, because that predates me a little bit. But then once his code evolved to the level, then we started cutting our stuff over to using the open source gem. Yeah. Does that make sense?
Yeah.
Do you have any, do you guys use the front end, JavaScript stuff at all, Relay or Apollo?
Yes.
And if so, do you have experience with both Relay and Apollo, or do you have your own stuff that you use?
It's a good question. Because Shopify is enormous, we use everything you can imagine. With front-end stuff, it's a little more scoped. We don't use Apollo for anything, but we certainly use React now for a bunch of stuff. So React is very easy to work with GraphQL out of the box. You plug in Relay to React, and everything we've written just works. We have a sample app that we're going to pump out soon, assuming we make this public, where it's I think I myself, I'm not a JavaScript developer, wrote like 100 lines of Relay code and React, and it's like an entire Shopify like browser for your shop, right? So things like that, we're pretty heavily invested in, and we would like to at least support fully developers using any framework they want with the JavaScript SDK that we ship. So our SDK won't pull in any large dependencies because we want people to use Apollo or whatever. And the goal is if they use Apollo's GraphQL client, things will still work.
GraphQL is very tight in the system. So at which level do you manage the private and public field, or do you go by the endpoint where it enters the GraphQL query?
Right. So for private and public fields,
Or object type, I don't know which level you.
so what do you mean? How do we control access to private things?
Yeah, or do you go by the field and then you resolve it
Yeah.
differently?
So on every field, I don't know how much I should show. Let's
Yes, please.
let's do. So yes, so on every field we have this required access, and we have any kind of lambda that you want to run at the time of request. So every time a GraphQL request comes in and is deserialized, this block runs and verifies that. In this, actually, this is a great example. It literally says if the context shop owner equals the shop being requested, allow access, right? So that's where we do that kind of resolution. Yeah. And maybe one more before we give it over to Sure, go ahead.
So at the beginning of the presentation, we talked about like, the wins you've had.
Yes.
Were there any like losses? Any things that are now like slightly worse than they used to be?
Yeah, for sure. So REST is like the native language of almost every backend and front-end developer when it comes to data access. One of the losses we've had is that I'm like on a GraphQL team at Shopify, but like the second that we shipped mobile Shopify, like half those guys just left me in the wind, and I'm like, oh fuck, it's like 3 of us. So that sucks. We're trying to now form like almost education and advocacy internally to push to the other teams that are about to build or consume APIs to use GraphQL. So that's more of like, maybe that's a factor of our scale and size and multiple offices and all that crap. But the biggest loss has been on the people level. On a technology level, we haven't done anything that's really bit us yet. Caching is going to be a tricky one. I would probably warn anyone looking at this that we've mitigated most questions around caching so far, but that will be the hardest technological barrier.